Okay, let's do some math for fun. Here we are going to calculate the sum as n goes from 1 to infinity of sin n over n again. But this time we'll be using the Fourier series for this. However, I didn't come with the following solution. I want to thank Boolean for the solution. Thank you so much. As you can see, we have the Fourier series and the Fourier coefficients on the board already. The first step is we just have to figure out what the function to use, right? Well, all we are going to do is we are going to let f of x equal to x. That's all. In fact, if you let f of x equal to x, you can come up with a few really interesting series. I'm going to show you guys two. Of course, that's one of them, and I'll show you guys the alternating version of that. Anyway, when f of x is equal to x, we are going to put it here and to figure out these things, right? When we have just x, of course, x is odd. When we integrate this over negative pi to pi, of course, we'll just end up with 0. Likewise, f of x right here is x, and that's odd. This right here is even. Odd times even is an odd function. So, again, we get 0. Here, we wish that this is also 0, but unfortunately it's not. This is odd times odd is even, right? An even function, and just have to integrate this, and I think you guys can trust me that I can do my integrals. I believe you guys can do yours too. So let me just tell you guys the answer right here is 2 over n times negative 1 to the n minus 1 power. So be sure to just integrate this by part and plug in numbers and do all that stuff. All right, now, take a look right here. F of x is equal to all that, but a0 is 0 and an is also 0, so that makes this part equal to 0. That means we just have to declare f of x equal to this part, and of course f of x is just x. So let's go ahead and write that down. We have x being equal to the series when n goes from 1 to infinity. And we have the bn, which is just that. So let's just go ahead and put that down. 2 over n times negative 1 to the n minus 1 power. And then we multiply this by sine of nx. So that's pretty much it. Well, if you want to clean this part up first, because if you look at this and that, maybe we can divide both sides by 2, so why not? Let's go ahead and do that. In that case, we get the sum as n goes from 1 to infinity, divide both sides by 2. We get, perhaps let's put everything on the top now, negative 1 to the n minus 1 times sine of nx over n. This right here is nicely equal to x over 2. This right here is x over 2 on the interval from negative pi to pi. Well, if you let x equal to 1, let me just put this down right here for you guys, just for fun. If you let x equal to 1, which is, of course, on this interval, put x here and put x here, and you have a really nice series. And in fact, you end up with the alternating version of that guy. So when we do that, let me just write it down. We will end up with the sum as n goes from 1 to infinity. This and that stays, which is negative 1 to the n minus 1 power. Put 1 here, of course, we get sine of just n over n. This series is nicely equal to 1 over 2, namely 1/2. Very, very nice, isn't it? Very, very nice. Well, how can we go from the alternating version to the original? Don't take the absolute value, it doesn't work. Here is the deal. We have to think about how to work with the x right here. So let's go ahead and continue. Let me just tell you guys that we are going to let x equal to pi minus y. And you will see when we put this right here and right here, things will work out very nicely. Let's continue. Put this right here down first though. And we get pi minus y over 2. And this is equal to, of course, this side, which is just the sum as n goes from 1 to infinity, and we have negative 1 to the n minus 1's power over n, and we have this, namely sine of nx. And the x is this now, so I'll just put down pi minus y right here, and that's very nice. Even better, of course, we can distribute this, and we just get n pi minus ny. And don't forget, we have sine of this minus that. Of course, we have the angle subtraction formula, so let's use that. So we get the sum as n goes from 1 to infinity, and this is negative 1 to the n minus 1's power over n. And this right here is going to be sine of the first, which is n pi, times cosine of the second, which is ny. And for the subtraction, this is also subtraction. And we do sine of the second, which is ny, times cosine of the first. Cosine of n pi, like this. Well, as you can see, this is very nice because when we have sine of n pi, keep in mind n is just a positive whole number. This is always going to be 0. So the first part is very nice because this is just gone. And if you look at sine of n pi, if n is 1, 2, 3, 4, 5, and so on, sine of pi is -1, sine of 2 pi is +1, so you get -1, +1, -1, +1, and so on. This right here, we can write it as -1 to the positive nth power because we have n goes from 1, 2, 3, 4, 5, and so on. So that's good. And we do have another negative right here to help us out. Check this out. This is gone already. Let's continue to write down the following. We have the sum as n goes from 1 to infinity. And here we have -1 to the n minus 1's power over n. All in all, we have the following. This right here, I will just keep it as sine of ny. But this times that, of course, this is like -1 as well, so we can just put them together and we'll write it as -1 to the n plus 1's power. Well. The beauty is that, oh my god, you see, this guy times this guy all together, they will give us just +1, right? Because when you add the exponents up, you will just get 2n, and -1 to the 2n's power is always +1. So, all in all, this right here, right, it's just the sum as n goes from 1 to infinity, and we just have sine of ny over n, like that. And let's see, what do we do next? Of course, we let y equal to 1. And is that legit? Yes, it is. Even though we shifted a little bit, but if you check the y, well, y will be going from 0 to 2 pi. You can just check that on your own. So that's the deal. From there, we're going to say let y equal to 1. Let me put on the left-hand side first. Namely, we'll just get the sum as n goes from 1 to infinity, and we get sine of n times 1. So that's just that, over n. And this is equal to, put 1 right here. So we get pi minus 1 over 2. Oh my god. So cool, isn't this?
Wow!
Yeah. Anyway, thank you guys so much for watching. And again, thanks to Boolean for the solution.